In this video, we're going to be starting in on a new unit on the algebra of functions. I think we're going to start off with just reminding you about just the concept of a function. So if we had something like f of x equals x squared plus 4x plus 5, and you were asked what's the value of f of 3, we would be plugging in 3 for x. Wherever we would see x in the formula for f, we would replace it with a 3. So we're starting by squaring 3, then adding 4 times 3, and then adding 5. And so that's going to be 9 plus 12 is 21, and 5 is 26. Yeah, but we want to kind of extend that idea today a little bit. So we might think about putting something else into f besides just a number. So, I think kind of an easy place to start would be f of t. What would happen if I plugged in t wherever I saw x? Well, I'd just square t. Okay, that's t squared plus 4t plus 5. But then I could, make it a little bit more interesting and ask, like, what happens if I plug the square root of x into f? And that's really what we're going to be talking about today. So really, we're going back to the idea that f of x takes x and squares it, adds 4 times that, and then adds 5 after that. F of square root x is I'm going to take the square root of x, and I'm going to square it. I'm going to add 4 times the square root of x, and then I'm going to add 5. Okay, we could simplify that a little bit if we needed to. We could say, all right, square root of x squared, that's just an x, plus 4 root x plus 5. And what we just did there, where we plugged one function into another, that's called composition of functions. So when it comes to, evaluating composite functions or writing an equation for them, what we're doing when we see like f of g of x, really just like g of x in parentheses inside of f, what we're doing is we're plugging g of x into f. And what you're going to remember is that if we're trying to write an equation for a composite function like this, any x you'll see in the formula for f, we're going to replace it with a g of x. And I'm going to really recommend that you replace it with a g of x in parentheses for reasons that I think you'll see here in a second. So we're going to start off with an algebraic example. So let f of x equal the square root of x plus 1 and g of x be x squared plus x. Okay, we're going to find f of g of 3 and g of f of 3. And so when we're just finding it, at a particular x value, I find it's easiest to just like start off with, okay, with this first one, I'm going to start by finding g of 3. Okay, so first I need to say, all right, g of 3 is going to be equal to 3 squared plus another 3. So that's 9 and 3, going to be a total of 12. And then I'm interested in taking f of g of 3, so that's going to be f of 12. And that'll equal the square root of 12 plus 1, which is the square root of 13. There's not really anything I can do with that. I'm just going to stop there. Okay, so that's f of g of 3. If I wanted to find g of f of 3, okay, I'd need to start by finding f of 3. Oops. Okay, so I'd say, all right, f of 3 is going to be equal to the square root of 3 plus 1. That's the square root of 4. Remember, when we see that square root, that means the positive square root, so it's going to be equal to 2. And then we're going to be interested in taking g of 2, because we were wanting to take g of f of 3, and g of 2 is going to equal 2 squared plus an additional 2, and that's going to be 4 and 2 is 6. Okay. But then for f of g of x and g of f of x, that's what I'm saying, anytime you see x, replace it with the formula for g, in the case of the first one. All right, so for f of g of x, I'm going to say, all right, so I'll really emphasize it this time. F of x equals the square root of x plus 1. So if I'm plugging in g of x, here, I'm going to plug in g of x there. And so I'm going to say that that's equal to the square root of g of x is x squared plus x, then plus 1. Right? And for g of f of x, I'm going to say, okay, well, g of something is equal to that thing squared plus that thing. Okay, so g of f of x is going to be f of x squared plus another f of x. Okay, and f of x is equal to that square root of x plus 1. So I'll say that's the square root of x plus 1 squared plus the square root of x plus 1. Okay, I can simplify that a little bit because I know how to square the square root of x plus 1. This is going to be an x plus 1 plus the square root of x plus 1. And I'd say that's a pretty good example of, evaluating composite functions at a point and just in general. Right, now, oh yeah, I remember this one. I like where this one's headed. So f of x is x to the 3 plus 1, and g of x is the cube root of x minus 1. Find f of g of x and g of f of x. Right, well, I'll do f of g of x. Right, so remember, f of x is equal to x cubed, and then add 1. So if I take f of g of x, which is going to be the cube root of x minus 1, that's going to be equal to the cube root of x minus 1 cubed. Okay, so cube root of x minus 1 cubed plus 1. Okay, and I know how to cube the cube root. Okay, this is going to leave me the thing on the inside, so that's going to be x minus 1 plus 1, and that's just going to be equal to x. Now I might clear out that highlighter to avoid any kind of confusion, but g of f of x is going to be, all right, well, g of something is equal to the cube root of that thing minus 1. Whatever that thing is, and I can see that thing is going to be x to the 3 plus 1. Okay, so I'm plugging in f of x, g of f of x, and f of x is x to the 3 plus 1. It'll be x to the 3 plus 1 minus 1. Okay, that's going to be the cube root of x to the 3, and that's just equal to x. Okay, now notice how f of g of x was equal to x and g of f of x was equal to x. We'll be interested in that in the next lesson. That means that f and g are inverses of each other. We don't really know what that means yet. So I was just going to show you what happened. All right, now let's do a couple of examples with like a graphical or a numerical perspective. So, you might be given a graph or a table for a function and ask these same kind of questions. And so these first couple at the top, I just want to remind you about, reading a graph or reading a table. When we say f of 2, we're talking about the, y-coordinate that corresponds to x equals 2. So if we're looking for f of 2 right here, we're going to go to where x equals 2 and look for f of x, and that equals 4. So I'm going to say f of 2 equals 4. Okay. Then h of negative 1, okay, that's where we're going. We're reading a graph. That's the y-coordinate that corresponds to x equals negative 1. I know you already know this, but I'm just looking at that point right there. That's the point negative 1, 0, the y-coordinate 0, so h of negative 1 equals 0. Okay, so why don't you try these next 4 on your own? Okay, so start with the inside, evaluate like f of 2, f of 3, f of 2, and h of 2, and then plug those into the outside function, and just make sure you know what you're doing. But then you can check your answer against mine, which is going to pop up here in a couple seconds, so you should pause now. All right, so there you go. And really, I think that, the two things that we've done, like kind of plugging one function into another and then evaluating on a graph and table, that's exactly the level you need to be at for Algebra 2 composition of functions. The whole theory of functions, this is something we're really going to expand on in pre-cal and calculus, so we're kind of just getting started on our journey here. Now, before I move on to talk about the next thing, like transforming graphs of functions, I want to do one more example that'll kind of point out to you why I really recommend you throw these things in with parentheses. I realize that hadn't quite happened yet. So I've got these two polynomial functions, f of x is x to the 4 minus 4x to the 3, and g of x equals negative x. And first we're going to start off by finding g of f of x. Okay, so remember g of f of x, wherever we see x in the formula for g, we're going to plug in an f. So that would just be right there. So it's going to be negative f of x. So g of f of x is going to be negative. Instead of x, it's an f of x. But I want to put f of x in with parentheses, right? Because I've got an x to the 4 minus 4x to the 3, and I would need to distribute the negative over both of them. And this is kind of not even the one I was mainly talking about, but this is something we need to be careful about as well. What I was really thinking about was f of g of x. Wherever we see x in the formula for f, we're going to replace that with g, which is going to be a negative x. But, okay, then, you know, taking negative number to even versus odd power, that's where we need to be careful, right? So I know that if f of x is x to the 4 minus 4x to the 3, f of g of x is going to equal g of x taken to the 4th power minus 4 times g of x taken to the 3rd power. And just remind myself about the order of operations and everything, and because my whole point here is that you need to use parentheses, I'm going to throw g of x from inside some parentheses. And then I'm going to replace g of x with negative x. So I take negative x to the 4th power and negative 4 times negative x to the 3rd power. Now if I take negative x to the 4th power, I have 4 negative 1's and 4 x's. So I'm going to have an x to the 4th, but I'm going to have positive 1 x to the 4th because, you know, negative times negative is a positive. So really, these two together would make a positive x squared. And then the other two together would make another positive x squared. I end up with positive x to the 4. And then if I just had 3 of these, well, I'm going to make that happen. Okay, then I'd have 3 negatives and a negative 1 to the 3rd power. That's going to be negative 1. Okay, and then I'll have... So what I'm saying is that this is equal to negative x cubed. So minus 4 times negative x cubed ends up becoming x to the 4 plus 4x to the 3 in a way we might not expect. Okay, so that's why I'm saying we need to be judicious with our parentheses here when we're plugging one function into another, because sign errors can occur. Okay, so I think that's all I've got to say about composition of functions in this video. In the next video, I'll talk about what this means for the graph of a function if we're to plug in certain compositions, and how we can look at that as moving stuff around. But I'll save that for a separate video. That's all for this one. Thanks for watching.